yeah, in the beginning, I want like to show you the static system because we didn't discuss about it before. This is the interface, and there is going to be different tasks during the course. Tasks organized in the lesson. So this is the first lesson, and there are like tasks. And here you have the field where you can like put your code. And in my advice, it's not like to right away to put something here, but probably to work on it locally in the beginning, because it's like in my mind better to figure out what is happening, like to debug your code. And let's just open as an example our first folder with the week 1 code. And then, so, I mean, like locally, you can organize it in any way as you like. I'll just call it homework.py. And so the first task is like write a program that prints the hello world string. And we already saw basically how to work with it. I mean, like if you want to print something to standard output, we should use print function. And here you can see that we have, as an example, there is some sample input. And in this case, it's like empty. It means that we don't need like to read anything. And usually if you see that there is something in sample input, that means that you need like to use default input function to read this input to your code. In our case, we just need like to print something. And basically, so the solution would be print hello. I mean, and you should like be careful, because if you see some output, that means that it's supposed to be, in most cases, to be the same, especially if it's like just some string, then it should be match exactly. In this case, we can like just copy and paste it, and this is a result. So we have like just hello world. Then you can try to just run your code, and you see that the standard output is hello world, and now you can try to submit it. Definitely you can try to do it like right away in the static platform, but just like, I don't know, in my mind it's better like to work locally than like just submit code, because sometimes when you need like to debug and also it doesn't have like a nice support for you. I mean, like it's not gonna autocomplete anything for you, but when you work locally, you can see that there is like some suggestions that I can use like print function and some other stuff too. And let's just submit it. And then there is some validation process. In some cases, there are like multiple tests which gonna be tested against your solution. In this case, there is no many of them, just like one test that the output should correspond exactly to hello world. And you can see, so you finished the task and you got 1 point. And basically later in the course, we will have like different tasks which gonna cost more points than 1 point. And when I said that you will get like, for example, 100% of the points per task before solve deadline, that means that you will get like 1 point. In the system, you will not see that there are like some differences. It's gonna be afterwards when I like build the spreadsheet with the results. I will take into account the date and time when the solution was submitted to the platform, the correct one. And you can, yeah, as I like mentioned last time, you can try to submit as many solutions as you want, but generally, so I mean, like sometimes I saw that people, you know, like they're trying to submit the same solution for the same task. I mean, like, so for example, there is a wrong solution, and somehow people trying to submit the same solution. I don't know why. They expect that it's gonna change something. Maybe if there are like some, for example, tasks for that take into account some randomness, probably it's possible to submit the same solution and then like kind of hit the correct result, but usually it doesn't work in this way. So this was like a very simple example. Let's go to the next step. And here we see, in this case, now we have some input. Here we have like some input, and we need like to take it into account. So we have like 2 lines, and you definitely should like read the descriptions of the task. So you can see that we have 2 strings, and then we should concatenate them. And let's just like try to resolve this task. And in this case, there could be like multiple solutions. So for example, I can create two variables and then print x plus y. So let's just try it. Probably it's gonna be okay, but who knows? You never know. Yeah, this solution works fine. And in my mind, so for the same task, there could be like multiple different ways how to resolve the task. So for example, you could like right away, without any extra variables, just like to use this thing. And basically it's like the same. Here we just like stored it in some variables, but we can like avoid storing it and just like right away print the result. And this is a sample output. You can even try to check it. So for example, hello, and then world on the new line, and the result is hello world. So everything works fine. And sometimes I give you tasks where you don't need to... okay, so this is the same. This one I will skip. This is the idea pretty similar. So you need like to get input 2 times and then like output the result. But sometimes you can see that there is a node that your program shouldn't print anything, and actually it shouldn't read anything too. So there is no input, there is no output. There is like some tests which gonna like test your solution, but it's like very important that you're not trying to print anything here, because in case if you try to print something, you will get an error. And so here we need like to create a variable y and assign it the same value as variable x. And basically this is a solution. You can see there is some nodes that you can use x variable in your code. And here we used it, we assign the value of the x variable to the y. And let's just submit it. Yeah. In this case, you also can debug your code, but locally. And locally you can use input functions, print functions, but in your final code, you should not use them here. Because, yeah, just like as a node here, the same node, and basically that's it. So usually there are like multiple ways how I provide tasks. In some I provide the sample input, sample output, but sometimes I just wait for you to kind of write some code without any extra input and outputs. So guys, this is about this like system for checking your solutions. And as you saw, there is a deadline. So deadline is gonna be next week. It's like October 17th. So that means that it's better for you to resolve all the tasks before then, because the final score gonna be dependent on your resolved task. So and basically, if you reach like 95% of all possible points, then you're gonna get A. From 90 to 95 it's B, from 85 to 90 it's like C, and in this way, so with a kind of step of 5%. Yeah, so this is basically about the homeworks and about the final scores that you will get. Probably, I'm not sure, probably we will have like one task which I will check manually, so you need, I'm not sure, I will think about it, that you need like to provide your code, to show me your code, and then I will ask you some questions about your code in a discussion. But I'll think about it, so it's not like for sure now. But the static part definitely is very important, so you need like to resolve it. And you can see, so there are like some people who already started like working on the homework. You cannot check their solutions in general, so you can write your comments here. But this part, so usually I don't check at all. I mean, like if there are like some comments here, I don't look on them, because it's like, I don't know, I don't use it in this way. And it's better, so if you want like to get some answers or raise some questions, then for example, right now, just use the Telegram channel. Yeah. And after you solve the task, you can go to the solutions. So if other people kind of submitted their solutions, you can take a look on their solutions and compare. So basically I can suggest you to provide your solutions after you resolve the task. So this is for example, my solution, and there was a way how to Yeah, I don't remember. So basically you can probably just submit here. So you need like just to click, and then it's automatically attach your last submission, and you can write, so this is my solution, for example. And then other people who solved the task will be able to check your code. And basically it's nice because sometimes you can see that the people use like very elegant or very like nice way of resolving the task, which you could miss, for example. Even I, for example, sometimes I see that the students provide some very nice solutions, and I'm like, yeah, that's very cool. So this is about the homework part. And if you have any questions, then please feel free to ask them. Okay, then let's go to the today's lesson about new topic. So I'm gonna close this. I'm gonna close this as well. And let's create a new folder. I will open it right away. And today we will talk about lists in Python. Lists and some other iterable objects in Python. And basically, where is my... So yeah, let's just go to the website. And here is an example. So we're gonna learn new built-in data types in Python. Before we saw that we had some basic data types such as integers, float numbers, strings, but sometimes we want to have a more kind of flexible way to store multiple values. And for example, let's assume that we need like to measure the stress level of the person and store all measurements that we have. And basically, so I don't know, probably a lot of you already have like this kind of smart watches, and they perform like a lot of different measurements over the day. And in this way, so for example, imagine that you want like to measure, I don't know, each hour some features, like as a, for example, heart rate, or also like the oxygen level, something like that. And in this case, if it's like once per hour, and then like we have like 24 hours in the day, then we need like to store somehow 24 values. And we could probably create 24 variables and then like read them, store them in this like multiple variables, but it's not very convenient. It's gonna be hard for us then to handle it. And in this case, we can utilize some inbuilt structures, data types, such as lists. And in this case, we will be able to store the information about some multiple measurements. And here is an example. So for example, that in the beginning we measured it and the stress level was like very low, then something happened, it like goes up, and then something terrible happened and the stress level is like very, very high. And we want to store these values in a code. And also I want like just to show you as an example where also like more kind of related to you, it's the gene expression data. So we can, for example, open the Fantasus. I hope that you already saw it, and let's just open some data set. For example, the basic data set that always used as an example. And in this case, you can think that you have like multiple measurements. Let's just focus on one specific gene. I don't know, I took just a random one. And in this case also we have like multiple measurements for the specific thing. In this case we measured like the expression level of COPG1 gene. And you can see that we have like, I don't know how many, probably 16 measurements, right? And we could, for example, create 16 variables and say that this is a value 1, value 2, up to value 16, and assign the values that are real expression levels of the gene in this gene for sample. But let's assume that you have, I don't know, like 100 samples, right? And in this case, you need like to create 100 variables, which is like completely not very nice way to handle such thing. And because of that, we will use lists. You will be able to store as many as you want, like values. And there is a very nice way how you can then later on in your code work with the values, like reassign them, perform some like normalizations and so on. So let's just create a new file, and then, for example, we can create a variable, call it like a stress level. And to create a list in Python, we will use specific syntax, and it starts with square brackets. And then inside of the square brackets, we need like to put values and separate them by comma. And as in our example, so for example, let's think that in the beginning we completely didn't have any stress level. Then, for example, person went to the work, something like started happening there, and the stress level like started like going up. And I don't know, when at some moment person had like a meeting, for example, right? And then like there is a huge like responsibility, stress level is like very high. And in the end, so the day is like almost done, so he's going back from lab or from the work to home, and then like stress level is going down. And in the end, it's like very nice. So person like watches some TV series. So that's it. And now we have like a lot of measurements here. And after that, you can just operate with this data by using the variable name. So you can see that we assigned this list to the variable which is called like stress level. And now after that we can use the variable name to handle this object and to kind of operate with it. Let's just run our program, and you can see that we printed the result. And there is a thing which is called like so basically I didn't mention it, and you can put different data types to the list. So it's not like stricted. You can like mix different data types inside of the list. So it could be, for example, string, then you can put integer number and the float number. Why it's important? Because in some other like programming languages, sometimes you can create something which is called array, not a list, and usually it's more kind of stricted. You can store just objects of the same data type. You cannot mix them, and it kind of in some way bad because it's not so flexible, but also in some way it's like better, because if you have like some fixed data type, then you can perform some operations in much faster way rather than in this like general list structure. And important thing for us is indexing. So let's assume that we have numbers from 10 to 100 with a step of 10. And then in Python we have indexation. So basically we can get the access to each element from our list by using the indexing. And the indexation starts from 0. 0 corresponds to the first element, then 1 corresponds to second one, 2 to the third one, and so on. And basically here is an example that you can then get the access to the specific element by using the indexation. And to utilize indexation, we need like to put the square brackets after the variable name which is assigned to the list and specify the index. Let's just try to use it. So when, for example, numbers 0 corresponds to number 0. And also let's try something else. For example, number, but number, not number, numbers. And we will get like 10. And for this one, guys, so what's gonna be as the output? So you can take a look on the website, try to match the indexation with the elements and say what's gonna be the result of numbers 3.
Why do you write numbers 2 times in these brackets after print?
The first one is a string. It's like just I wanna like just to show, so you can avoid this part if be honest, but it's like just for simplicity, so that the string. Yeah, let's just remove it for now.
Just we want to label it, yeah?
Yeah. Just like as a kind of label before the real output of the result.
Okay.
Yeah,
Yes,
so
I see.
let's like remove it just like for simplicity, and then we will put it back and we will see how the output looks with this extra string in the beginning. So guys, don't be afraid. If it's like wrong, it doesn't matter. I mean, like you can just try. So number 0, as we saw on the example, so index 0 corresponds to the first element, and number 0 supposed to be 10, and then number 3, like with the index 3, it's gonna be any ideas, guys?
40?
Yeah, nice, 40. That's right. So let's just run it, and this is the output. And basically, so as I said, indexation is like the way of how we can get the access to the specific element from our list. So we have like some objects in the list, and then for each object we have like a corresponding integer, which kind of from 0 to, in this case, 9. We then can utilize the indexation to get the access to specific element. And let's just put back extra strings that were before. Now if I execute it, you can see that we just like kind of added what we are like executing later on. So we executing numbers of 0, and numbers of 0 corresponds to the 10. Numbers of 3 corresponds to 40. And this is about indexation. And now, for example, also we can utilize indexing to change values inside of the list. Because let's assume that you made a mistake when you were like filling the list, and now you need like to change some values inside of the list. And in this case, you can also utilize the indexation. So number 0, as we know now, corresponds to this value, and we, for example, can reassign it. Let's say that I want to put 0 instead of the 10 to the list. And now I can print the whole list, not just a specific element, but the whole list. Let's run it. And you can see that in the beginning numbers of 0 was 10. And now, after this like operation, we changed the first element in the list. So, and here is an example of the thing that also Python has, that you can utilize the negative indexation in reality. So basically, when you have a list, you have the indexes which starts from 0 up to length of the list -1. And in the same way, there is a negative indexation, and -1 in this case corresponds to the last element, -2 to the second last, and so on up to minus length of the list, where minus length of the list corresponds to the first element. And this could be like slightly different in case if you saw, I mean, like if you already worked with R programming language, because in R programming language, whenever you use minus indexation with, for example, arrays, then usually it works that you exclude this element from the array. And basically it's a difference. But in Python, you can easily access the last element if you need by using the -1, then -2 for this one. And let's just try to print some values with minus indexation. So for example, it's like -1, and then for example -3. So let's just execute it, and you can see that we really got the last element, and then -3 corresponds to 80. And this is a very nice way to, in case if you need like to get the last element, for example, sometimes there are tasks where you kind of focused on the head of the list and then of the tail of the list. And in this case, you can operate with negative indexation rather than think about that there is a length of the list. You need like to write length of the list minus something. And it's a way how you can also get access to the elements. Yeah, and here is an example that you, in the same way, can use like negative indexation and then like change the value inside of the list. And now let's talk about the slicing, because in this case we just got one element as a result. But sometimes we want like to get the slice of the list. It's not going to be just one element, but it's like multiple elements from the list, and we want like just to get this part of the list. And in this case, we can utilize the slicing approach in the Python. This is a general syntax of how the slicing looks like. And let's imagine that we have like some list object, then we can open the square brackets and utilize this syntax to specify the range of the elements that we want to get as a result. So in the beginning, we can specify the start position of the start index, stop index, and then also the step size of our slice, for our slice. And here like just the same thing that I already said. And let's just take a look on this example. So we have again the same list of numbers from 10 to 100. And here is like different ways how we can utilize the slicing. And the important thing that, as we saw like with the range functions, there are like some default values for start, stop, and step. So they're very similar, the slicing and the range function in my mind, because you have like a start. In range, you can also specify start. Then you have stop, the same as a range function. And the default value for start is 0. For stop is like the length of the list. And step usually by default corresponds to 1. And here, for example, numbers of 3, when we put it in this way, so Python knows that by default the first index start is 0. And because of that, we can like kind of omit it, just like to be a little bit lazier and utilize the implicit way of specifying our slice. But in reality, so this statement similar to specify the whole slice with all arguments. So numbers column 3 corresponds to numbers 0 column 3 column 1. And then this thing corresponds to numbers 3 and then length of the list. In our case, the length of the list is 10 because we have like 10 elements inside of the list. And the step size is 1. And then you can omit start and stop position, and you can just specify the step size. And this is a different ways how we can specify slicing in our code. Let's copy and paste it. And let's execute it. And you can see in this case, for numbers column 3, we got the part of the list. And basically we got first 3 elements in the list. And then when we specify the second statement, like numbers 3 column nothing, it's gonna give us the rest part of the list, which is started from the index 3. And as we remember, index 3 corresponds to the 40. And you can see that there is like some similarities, because if we specify stop index, it's not gonna be in the interval for the indexes. And in range, we also saw that in range function, when we put like range of 10, the last element that we're gonna get from the sequence of the integers is gonna be 9, but not 10. And this is just because in Python the indexation starts from 0, and in reality we need like to do it in this way to be kind of consistent with the range function, with the list indexing order, because we're gonna use a lot the for loop with the lists to iterate through the elements. We will see it like later on. But this is a slicing, very nice way of how you can get a part of the list. In this case, you can see that we specified that we want like to get the first element, then like avoid the second one, get the third one, avoid the fourth one, get the fifth one, and so on. So this is a very cool way of get a part of the list. And guys, if you have any questions, so you can ask them. Okay. Yeah, and this is just a visual example how it works. So for example, when I specified numbers 0, 4, we take all indexes from 0 up to 3 because 4 is excluded, and we will get the first part of the list, like 10, 20, 30, 40, and then also if we specify numbers from 4. Okay, there is another example. We haven't seen this function yet, but basically it's like we can get the length of the list by using this function. Yeah, probably I should remade it a little bit to make it consistent with the code that I provided here. And now I want to show you some interesting thing about the list assignments. It's like a way to assign a list to another variable. So for example, here we have numbers 1, it's a list of our numbers, and then we created a new variable which is called like numbers 2, and we're trying to assign numbers 1 to the numbers 2. And then in numbers 2, we want to change the first element and switch it from 10 to 100. And here is a question. So what do you think stores in the numbers 1 variable after this code? You can take a look, you can think about it, and just like give me your ideas. But try not to kind of write this code in the editor.
Maybe it will be changed also.
Yeah. So basically, like expectations that it's not going to be changed, right? I mean, like from the point of view that you created a new variable, you assigned a list. So usually, I mean, like from my point of view, I would expect that it's not going to be changed. That numbers 1 will be still the same, but in reality, it's going to be changed. And there is an example why it works in this way. So let's copy and paste this example, and then let's print numbers 1. And also let's print the numbers 2. So you can see that the both of them changed after this operation. And in reality, why it works in this way, that whenever we create an object, so for example, we created an object here, which is our list. And in reality, we kind of allocated memory for this object, and then we just assigned a name for it. So we said that numbers 1 corresponds to this object. And when we write like numbers 2 is equal to numbers 1, in reality, we're not creating another like object in the memory. It's going to be the same object, but we will just have 2 links to this object. And whenever we change numbers 1, it's going to change numbers 2. And for the case if you want like to create a real new object for the second list, we can utilize slicing, because after the slicing, we return a new object as a result. And here is an example how we can use it to avoid this behavior in case if we want like to really allocate a new object in the memory. So you can see that we have the variable which is called like numbers 1, the same list. And then here we use the slicing. And as you remember, so the first argument by default corresponds to 0. The second argument of the slicing corresponds to the length of the object. And the third one corresponds to 1. And basically it's gonna give us all these values as a result. But since we use slicing here, so this is the syntax of the slicing, we will create a new object with the same elements. And now if we change the numbers to, if we change the first element of the numbers 2 list, we will not affect the numbers 1 in any way. So let's execute it. And you can see that if we utilize the slicing, then the result is has another like behavior. And it's very important because sometimes you can like really faced with the issues whenever you work with the lists. If you forget about this behavior, you can rewrite some values in your lists. For example, if you like worked with I don't know, like in the same way, if you work like with gene expression data, and let's say that you created numbers 1, it's like just row counts of the gene expression, right? And then you forgot that you need like to really create a copy of the object, not the same object, and created a variable, called it like normalized values. Then you, for example, normalize the values, and in this case you're gonna lose, you can lose the row counts, and it could be bad because if you like really lose it, then in some cases, some normalizations, you cannot go backwards. For some of them you can, but sometimes you can like change your values and lose the values. And it's like just as an extreme situation, which not gonna happen in reality probably, because usually people not using the row lists to handle gene expression data or something like that. But still, there are like some caveats where you can face with the problems. So it's usually better to keep it in mind. And basically, why it like works in this way. Whenever we create a mutable object, and lists are mutable because, as you saw, we can really get the access to each element in our list, and we can change the value of this element. And this is a kind of main feature of the mutable object. And if you have a mutable object, then if you try to create multiple variables, and you just like using this syntax kind of to assigning the, like, for example, numbers 1 to numbers 2, in reality, it's not gonna give you a new instance, a new object. It's gonna give you just like a link to the same object. And since it's mutable, you're gonna mutate all the all the variables that you had. And it's a kind of important sometimes to take into consideration. Yeah, this is an example how you can, for example, check that the object the same for the different variables. And to do that, you can utilize the built-in function which is called ID. And basically ID is like ID in the memory where the object is. Let's just copy and paste. Let's go over. So we have a list of our numbers. Then we utilized the same syntax as in the first example. We assigned numbers 1 to numbers 2. And here's what are like the ID of numbers 1 and ID of numbers 2. And we will see that in this case, ID are the same. It means that the object which is like associated with numbers 1 and numbers 2 are the same in the memory. It's like the same object. But whenever we use the slicing, the IDs of the kind of underhood objects gonna be different. So let's execute it. And you can see, so there is a like very long number which specifies the ID of the object for numbers 1, for numbers 2, and they're like exactly the same when we use this statement. But when we use the slicing, we will create a new object in the memory, and the IDs are different. And this is just as a way how you can check in your program that the underhood object is the same. You can utilize ID function. It's not like usually, it's not like frequently used, but just you can, I mean, now you know that you can check it in case if you need it. And the very nice part about lists in Python, that they have like some extra functionality besides that we already saw that right now we know that we can, for example, get slice of the list, we can control specific elements of the list, but in reality there are like a lot of different methods which are inbuilt, and we can utilize them to work with the list. And for example, we can append some elements to the list, and in this case you need like to use the method, and the method is used in this way. So we have the variable name which corresponds to the list, we put dot after it, and then we need like to specify the method name. And append is a real method which implemented by the Python developers for us, and we can utilize it. In this case, we add a new element to the list. So let's take a look on the example how it works. I will just execute it, and you can see, so in the beginning we had our list of the stress level, and then we want to add a new element, and in this case we can use the append function. And now you can see that after we ran this code, in the end we added a new element to the list, which is like 100. Also, this one, like this is what I didn't show you, but in reality, if you don't want like to assign the list to any variable, and for example then you want like to perform indexation or slicing or running the method, you can also do it without any extra variable names. So let's say that I have just some random list, and for example now if I need like to get the first element from this list, I can use indexation here. Let's say that I want like to get the second element of the list. I can put the indexation right after the list, write it, run it, and I can get the access to this element. Also, you can utilize the slicing. So for example, like to go over through the all indexes which are even, and we get like 0, 2, 4. Just as an example that you don't need like to always store it in the variable. You can in the same way utilize everything after the real list, or you can like for example append here 5, and it's gonna work. Okay, append doesn't work because append, yeah, there is like some moment about it. So in reality we add this element to the list, but the whole construction is not like returning anything back. Yeah, but with indexation and also with slicing it works nicely. And there are like a lot of different methods that you can utilize. So for example, you can use the pop method. Also, you can go by the link and take a look on all commonly used methods that you can utilize with your list. So the first one is the append function, then there is a clear function, and there is a description what each method does. You can copy, count, extend, index, insert, and let's just take a look on some of them. So I copied the code from the website. Here I have again stress level, and then I can add not just one element, but I want like to add couple elements from another iterable object. And in this case, I put it the list here, and this is the syntax. So I will add 90, 80, 70 to the original stress level list, and then we will just print the result. Also here we utilize the pop method, and it's gonna remove the last element from the list. And then also we can utilize the sort method to sort the list. So let's run this code. And you can see so that in the beginning we added extra elements to our list, which are 90, 80, 70. Then we used pop to remove the last element. And then also we performed sorting for our list from like smallest value to the largest one. And for pop, in reality, you can save the value. So let's call it val pop. And it's not going to be none as we saw before. It's going to be a real value that we deleted from the list. Let's just make it more explicit. And you can see that we deleted 70. And this construction returns something as a result back. But sort, for example, doesn't return anything. And also this like append doesn't return anything. It's like just perform some operation in place inside of the list. So guys, is it clear?
Yes, that's perfectly clear.
Okay, nice. Yeah, so and here is an example about if you need like to delete some specific element, you can utilize indexing and use the del operator. There is also a way how to do it with the method, but this is a much kind of shorter way of how to delete specific element from the list. So we have like stress levels. This is just like before deletion. We have original list, and then we gonna remove the 10 from the list. So let's execute it. And you can see that we deleted 10 from the list by using the del operator. And in reality, del is like very powerful. You can delete not just a specific element, you can delete the whole list. Let's just check it. Delete stress level. And now if I try to print the stress level, we're gonna face with a problem. So you can see that we deleted the whole object and the whole variable which was assigned to the object. And yeah, so this is a very powerful. You can delete whatever you want in your program. Sometimes in case you need like to release some memory, because sometimes we are like working in Linux, like for example in system biology, sometimes we are working with a real huge amount of data. It can be like a very huge object, and then for example we store it in the memory of the computer and we don't want to overflow. And in this case, sometimes you can delete the object to release the memory and to not get the memory overflow, which is bad because it's gonna crash the whole program that you wrote, and you can kind of lose the time, because in this case you need like to rerun your program. Be careful with the memory that you had before. Yeah, this is about the deleting some elements. And also in the same way as we saw before with strings, we can utilize plus and multiplication operator. And in this case, for example, if we had just 0 and we use multiple 10, we're gonna kind of copy or like multiply the element that we had here. It's easier to just show how it works. You can see that after like list multiply by 10, we're gonna have 10 zeros. So, and it's a very nice way if you need like to create a list of specific elements, like just in one line, you can utilize this approach. Then after that, we have stress level, and we kind of concatenate two lists by using the plus operator. So here we're gonna get like list of three tens, and we added it here. So it's like kind of similar to the extend operators that we saw before, extend method as we saw before, but in this case we are using operator. And let's just also take a look that it can be not just one value here, it can be 0, 1. And now we repeated 0, 1 10 times. And in general, we have now 20 elements in the list. Yeah, and now, as you saw before, which was like a little bit too early, like as a spoiler, we can utilize the len function. So len function, it's a built-in function which gonna give us as a result the full length of the list. So this is our list. We know that there are 10 elements from 10 to 100, and len function works in the way that we need like to put len function and then specify the object inside of the len function. In our case, it's numbers, and it's going to give us the length of the object. And we got 10. So this is about the len function. And now let's take a look how we can like iterate through all elements in our list. In this case, you can use the for loop with the lists. In this case, we're gonna create a empty list. If you want to create an empty list, you can just put square brackets and don't specify anything inside of the list. And then inside of the for loop, here we gonna go through the sequence of numbers from 1 to up to 9. And here you can see that we use append and we adding one by one element to our empty list. And in the end, we're gonna get the list which contains from 0 to 9 sequence of the numbers. So, and this is an example that you can use for loop, for example, to fill your list. We will see that there are like other ways how to do it in more efficient way rather than this one, but it's just like as an example that you can now perform like some sequences, something. If you know that there is like some repeated process and you want like to handle some values of it, you can utilize for loop and mix it with the lists, because it's like the main concept that you have the list is an iterable object, and usually we want like to go over the elements and to perform some operations on them. And here is an example that we now can again like mix range function with the len function, and in this case we will go over through each element of our list and we will calculate the square of each value in our list. So, and you can see that we got like 0, 1, 4, 9, which are basically squares of the element that we had before. And let's just, as an example, let's just take a look what can be done. So in the same way, let's say that we have just empty list. Let's fill it in the same way. And now let's say that I want like to perform some normalization, because that's what we are usually doing with the values that we have like in gene expression data. And in this case, I'm gonna create, for example, the list of zeros multiplied by length of the numbers, and it's gonna be exactly the same length as we had like for numbers, and it's gonna be filled with zeros in the beginning. What is it? Okay, sorry. Yeah, here it should be just as a method without square brackets. So, and we just created normalized values, which are like for now filled with zeros. And now let's just calculate the mean and let's just calculate the mean. And I want like to normalize it in the way that I want like to just subtract the mean value from our list. So when mean value is equal to 0, for example, now we can go through the element of our numbers, and mean value is a plus equal the numbers of I, right? And then I need like to divide it by the length of the elements that we had. And now, for example, we can print the mean value of the original list. So you can see that the mean value is 4.5. And now we can go for each element in the normalized values. and subtract this value. And let's print the normalized values. So this is a full code. And when we execute it, oh, sorry. Yeah, it should be norm vals I minus min val. Sorry guys, sorry. Yeah, this is a normalized values of our list. And this is just as an example that you can now utilize the for loops to go over the values that you have. And basically, this is as a simulation of the possible work that you can perform with different values. And guys, so the question for you in general, so do you know like why we need like this all normalizations in case of the gene expression data, for example?
Well, if we have different data sets, they need to be kind of commeasurable. They like probably some data sets would have bigger values than others because we read some genes more times, and to kind of have the same scale. Yeah, we need to normalize them.
Yeah, that's exactly
Yes.
This is exactly the point of normalization, because in reality, for example, whenever you perform the sequencing or something like that, there is some factors which make the scale of the values that we got different, and we want like to be able to compare values, for example, for the same gene between different samples. And in this case, it's like important to get the proper normalization before any other conclusions that we're gonna make, because for example, if the library had like a different size, in reality we will not be able to right away to compare the row counts that we got like for one sample for another one. And because of that, there are like different approaches how to make them, how to put them in the same scale and then be able to compare the, for example, the differences between groups. And this is a very important step in the data analysis in my mind. And in reality, it's not just like specific for the gene expression data. You can find that this is a very common approach in all cases whenever you gonna perform the data analysis. For example, the scaling, whenever you subtract the mean value and then divide it by the standard deviation, you will see that this is a very common approach in any field that you're gonna take a look. In reality, for example, if you want to transfer the colors from one image to another one, you can see that there is a special color space. So you in reality you need to convert the images to one color space, and then if you want to transfer colors from one image to another one, you will perform exactly the same operation. You will calculate the mean value of the color for the image, and then standard deviation for the color in the image also. And then to transfer the colors, you're gonna normalize the second image, and then to add this information about the mean value of the color from the first one. So it's, I mean, I'm just waving with my hands, but this is the reality how it works, and this is one of the approaches in case if you need, for example, to transfer colors. Okay.
Yeah, this makes sense. And can I ask a question?
Yep.
In this example, we assigned 0 to mean value, right?
Yeah.
And then we made this loop for I in range of the length of numbers. Yeah. We kind of assigned each element in this new list. Yeah, the elements in our numbers.
You mean here?
Yeah, this one.
So here we basically, so mean value in the beginning was 0, right? And then we are going through each element in the numbers. And this is the same. This is the same operation as we would write mean value is equal mean value plus numbers of I. So basically we just calculate the sum of all elements in the list. and then to get
the sum.
Yeah, basically it's a sum of all elements in the list. And then I divide it by the length of the numbers, because this is a definition of the mean value. So we need like to sum up the all elements from the kind of array, and then divide it by the length of the...
Yeah, this is clear. Yeah, just this line, like this plus equal. Yeah, so it means that
this is exactly the same as just like mean value plus numbers of I. And since we are like going through each element, we will just sum up all them into one value.
Yes. Okay, now it's clear.
So yeah, and this is actually this we already saw, and this is that we can like modify the elements inside of the list. Since we already saw that we can modify elements by using the indexation, we can put the numbers of I and reassign the value in any way that we want in our code. So let's just put it here. And you can see, so before modification, our list is like just values from 0 up to 9. And then we reassigned each element in the list. And now we calculated these squares, and we have put them to the list right away. So in this case, we don't have like an extra variable. But in this case, we don't care about the original list. And because of that, we just can save our memory and perform all operations in place of this list. So, and basically, it's like usually very dependent on the task. Sometimes we want like to save the memory and don't to create copies of the objects. But sometimes we want like to have the copy, and it's really dependent on the task. For example, if we don't want to lose the original information, then we will have extra object in the memory. But sometimes we don't care about the original information itself. And in this case, we can perform some steps in place and to save the values. And in reality, for loop is a very powerful thing. So it's not just working in the way that we saw before. In reality, we can utilize this syntax to go over through each element in the list. So you can see that in this case, we don't have any indexation. We just put for element in numbers. And in this case, we will go through each element in our list. And this is a very nice way, because in this case, you don't need like to have extra indexation. You don't need like to think about it. Let's just execute it. And you can see we got the result like 0, 1, 2, 3, 4, 5, and so on. But there is also a note about it, that let's just have this example. So we have just numbers from 0 to 4, and now I use the same syntax to go over through each element in the list. And I put like for element in numbers, and then if I try to reassign the value inside of the list, this is not gonna work, because if we want like to reassign the element in the list, we really need to use the indexation. You can see that after this operation, after like going through each element, we didn't change the values inside of the list, because when we utilize this statement for element in numbers, we're gonna create a copy and put it to the element variable. And because of that, since it's a copy, we don't like affect the real values inside of the numbers list. So yeah, guys, it could be, so you can like think why there are like so many different options, but as I said, so it's really task dependent usually. For example, sometimes I know that I want like to go over the list, perform some operations, and be secure. I don't want like to change the real values inside of the list. In this case, I can just like use for loop and iterate through the elements without any indexation. and everything gonna be fine. But sometimes I want like to change the values. In this case, I need like to go through the elements and utilize the indexation. Now let's take a look how we can like in a more efficient way create lists and fill them right away in one line. So this is a syntax and statements that we saw before. So this is a list, and then we filled it with a sequence of integer numbers from 0 to 9. But in reality, we can utilize something which is called like list comprehension. And this looks like that. So we kind of wrapped the for loop inside of the definition of our list. And it works in the same way as this one. So let's just execute it, and you will see that this is indeed the same. So, and the syntax is like that. You need like to specify element that you want like to put to the list, and then this is specifies the range for the element to go through. And then we just like, we will put all these elements to the numbers. And this is I mean like probably in terms of the creation of the list, this is my favorite thing that I use a lot in my programs because it's very powerful. You can also add, for example, the conditional statement here. Let's just take a look how it works. And I'll like also describe it. So in this case, we also go through the 0, 1, 2, 3, 4 up to 9. But when we put the element to the list, we will multiply it by 10. So it means that we want like to put 0, 10, 20, 30 up to 90. And then you can specify the conditional statement after this like for loop. And here you can see that we want like to put just those values that are greater than or equal to 50. And now if I execute it, we just got like the values that are like more than 50 or equal to 50. And usually you can utilize it to filter out some values from the lists that you had. Yeah. And there are like some other things that you can utilize. You can put several for loops inside of the list comprehension, but this one probably is tricky one. So you shouldn't try to put everything to the list comprehension. Sometimes it's better to kind of explicitly split it into parts, because otherwise it can be very hard to understand what is happening here. Basically, in this case, we're gonna create a Cartesian product as we saw before, but here we kind of put the for loops inside of the list comprehension. You can see that we created like all possible pairs for I in range of 3 and for j in range of 4. I hope that you remember, so last time when we were like talking about the control flow, we also performed something similar, but in this case, you can see that we kind of put the for loops just like next to each other and created the all possible pairs.
Yes.
Yeah. So this is about lists, so it's like just some overview. In my mind, you need like to probably take a look more closely to the methods that I showed you. So there is a link, and you can see that there are like different methods for lists that can be used in the programs. And after that, yeah, so basically all other things also nice to have in your kind of toolkit whenever you work with the analysis of different things. And now I want like to tell you about the tuple data type. And tuple is very similar to list, but there is a one key differences between list and tuple. So tuple is immutable data type. That means that we cannot change single values inside of the tuple object. So let's just take a look. And to create a tuple, you need like to specify you need like to open the brackets, just like regular brackets, and then in the same way put values separated by comma here. And in this case, we create like a coordinates for the dot on a 2D plane. And you can see so that the values are integers. In the same way, you can like utilize a print function, print the values. Oh, it's like another program. So yeah, this is our like coordinates. And now, for example, if we try to change the value of the tuple, let's try to change the first element of the tuple. We will face with the error, and this is the main difference between the lists and tuples, that we cannot change the values inside of the tuples. And you can think about it in the way that sometimes, for example, we want like to store some constant values in our programs, right? For example, it could be like some mathematical constants that you want like to fix the values and you don't want to change them accidentally during the program. And in this case, you can utilize the tuples. You can create a tuple, specify these values, and you are not going to change them inside of your program. Yeah, and in the same way, so we can utilize the indexing with tuples as it was like with the list, and we can iterate through the tuples in the same way as we saw before for the list. Yeah, and now let's take a look. So if we want to check that there is some value and if it's like inside of the list, in this case you can utilize the in operator, because sometimes it's very important like to check is there like a value inside of the list. Let's just take a look on this example. Here I create my list, my tuple, and I just want to show you that this in operator works in the same way for lists and for tuples. So the first two statements for list and then the last two for tuple. So you can see that the 3 in my list, it's true because 3 indeed inside of the list. But when we try to check that 10 in the list, we will get that it's false. And in the same way for tuple it works. And in case if you want to check that something is not in the tuple, for example, let's check that 10 not in my tuple. So very like just like as an English statement, right? Like a statement in the English language. So 10 not in my tuple, and then the result's gonna be true because it's really not in the tuple. Yeah, and this is an examples about not in operator with tuples, with lists. It works like in the same way. And you can use length to get the length of the object for lists, for tuples in the same way. So that's it, guys, about the like lists and tuples. Just like as an example, let's take a look. For example, you can copy and paste, just like to make it more kind of relatable, how to put it into words, like to make it more okay, guys, my brain is not working anymore. Okay, like just to kind of in terms of the list, in terms of the genes, right? So this is our genes. Let's just create a, I will use some statements here which we haven't seen before, but in reality you will see it like later on in the course. So here is a multiple line string, right? And this is my genes. And now I want like to convert it to the list, and then I can utilize a special method for strings in this case. Let's just print it. You can see so that we converted the list of like the strings with our genes into the list. And now sometimes you want to check that there is a specific gene inside of the in the list of your list, right? So for example, let's check that there is no, I don't know, CD3E. Is it like inside of the genes? And you get that it's false. Also, you can check that there is like something which is indeed inside of the list. And this is just like as an example in terms of the strings and in terms of the genes. And in reality, for example, whenever you work with the analysis of single cell data, at some moment you are trying to find the most variable features in your data, which gonna be most variable genes, which are like showing the difference in terms of the expression between different cell types. And then you get usually as the output, for example, 2000 highly variable genes, and you want to check is specific gene inside of this like highly variable. And in this case, you can utilize the in operator, just as an example from the point of view of the system biology. Yeah, I mean like that. All these like small pieces, they really play a critical role in the analysis that you are going to do later on.
Yeah, and normally Python is used inside like our computers. I mean, for example, we work with some data sets, yeah, and we just like now we take this data and analyze it. So somehow.
So it depends usually on the program, but sometimes some of them indeed really depends on a Python. And it's especially so, for example, if it's something like very modern, something new, if it's like some neural networks, some machine learning tools, then indeed it's like there is a Python which is like working as a backend of your program. And just as an example, so there is a, I want like just to show you that it's like really right now nowadays Python is everywhere. Let me just show you as an example. There is a very cool models to generate images which are called like stable diffusion. So this is an example, and you can really download it from the internet. And if I go like to web UI, you can see so that there is a really Python program which is written in Python code. If I open it like with Visual Studio Code, there are like some statements, but basically it's like code that's written in Python. And whenever you run this program, it's gonna be like on a backend there is a Python. This is just as a script for the command line interface of the Windows. But now, for example, if I run it, it's gonna open for me the web interface, but the backend of it is a Python. So it's basically like all this like PyTorch, all these like modules, packages, which are like very popular for the neural networks, for machine learning. Yeah. And this is just as an example, kind of a little bit of off topic. But you can try. So in case if you have like a nice GPU on your computer, you can install it, run it, and play with it. Like, and in my mind, so for example, this specific one nowadays like perform very nice, and even like can be comparable to the Midjourney. You know that there is a Midjourney where you need like to pay $30 per month to be able to generate some images. But here, so it's not so fast because it's like depends on the GPU that you have. But you can put here like some statement and then like press generate, and it's not gonna be fast enough, but in the end you will get the result. And you can see so that there is a something is happening, and everything which is like happening on the backend. So all these like torch modules persist in Python. Yeah, so this is just...
So it's like the artificial intelligence using Python to
Yeah.
create images? Yeah.
Yeah. So yeah, guys, that's it. And as you can see, so I mean, like there is like same ideas behind it. whenever you like working with iterable objects, with like some other stuff, you can see so that we have like, for example, string here. So I mean, like string is some like basement, like a fundamental piece that's gonna be in all your programs, and it's like good to know how to handle it to be able to generate something like to generate some software by yourself.
Yeah.
So yeah, guys, that's it for today. If you have any questions, then like feel free to ask them.
Yeah, just in the program that you were showing, there was split lines thing.
Yeah.
What does this mean?
So basically,
Just split lines, yeah.
yeah, basically in this case, we will see it like later on, but you can see that we created a multiple line string here by using the syntax that we saw probably on the first or on the second lesson. And then this is a string object, and string object, in the same way as we saw today as a list object, has some inbuilt methods. And split lines method takes the string and then split it by the new line symbol and creates a list. And basically, whenever we have this like jump from one line to another, in reality, there is a hidden kind of character or like symbol. And in reality, the symbol is like this one. So it's a new line symbol, and split lines takes the string and split it into parts by this symbol. And because of that, we got the list here. And then we just checked that there's like something inside of this list.
Okay. So if it were one line, yeah, in the input, then we wouldn't use split lines.
Yeah, for example, if it's just like one line, let's take a look. So for example, if it's just one line, I want to replace it by one space. So this is now the same example, but one line. And now if I run the same code, it's not gonna work properly. So you can see that I got 2 times false, and I generated the list, but we didn't split it by the in the proper way, because we tried like to split it by the new line symbol, but in reality here it's not a new line symbol but a white space, right? And we can adjust it a little bit and use not like split lines but split function, and by default it assumes that we want like to split by white space. So let's just run it, and now it works again in a proper way. Oops. Yeah.
Okay, thanks. Now it's clear.
Yeah, welcome. So yeah, basically, if you, I mean, like you always can just copy and then, for example, go to the, oops, I mean, like just to Google it, and this is an explanation what split lines
Yeah, sure.
do. Yeah. I mean, like just.
Yeah, we do that when we do homework, but it's good to know that when you see it, yeah.
Yeah.
The more you learn, the more you know. So.
Yeah, that's true. I mean, like even I usually sometimes see some new methods that always were in Python, but I didn't use them before, and then I'm just like, okay, this is a nice method. I just need like to remember it and utilize it later on in my programs.
Okay.